Today we are going to discuss projectile motion. What is projectile and what are the different terms used in the motion of the projectile there? What are the expressions for those terms? We'll also see what are the conditions for getting maximum horizontal range and maximum height attained by a projectile. Now, for maximum horizontal range, is the angle of projection should be 45 degree, exactly 45, or there are some conditions applied there. We'll also see, is the time of ascent and time of descent are always equal in projectile motion? And what is the case there for a projectile projected obliquely? So all these we'll discuss in today's discussion. Along with that, we'll also discuss some conceptual type questions and some thought-provoking questions there. So all these will be discussed in today's discussion. So far, when we have done motion in a straight line, there the body is either moving in a straight line horizontal path there, or the body is only describing vertical motion. For that, the body is moving horizontally, maybe on a particular horizontal surface there, or the body is thrown exactly in the vertical direction there, or it is falling vertically. So in all these cases, separately, that is the motion along a straight line path. But when we take a projectile will be a body in flight which has not been supplied any fuel there. So it will be moving there, having horizontal displacement as well as vertical displacement. Because when it is thrown with some velocity, so that it can describe its motion in 2 dimensions there will be acceleration due to gravity acting on the body which is projected there. So that one will be changing its vertical velocity. Also, if the body has velocity, in that case it will have 2 types of motion there. One will be the horizontal as well as vertical motion, due to which it will describe horizontal displacement as well as vertical displacement. So its path will now not be a straight line, but it will be a parabolic one. So we'll discuss all these cases there. Of course, for the motion of the projectile, we neglect the effect of the air resistance. We also neglect the effect of the curvature of the earth. We also neglect the effect of rotation of the earth. Although all these will make a very minor change there on its path, on its velocity there. But in general, we are just neglecting in the simplest case. Also for the projectile, we can take 2 simple examples there or cases there. When the body is projected horizontally from certain height, or when the body is projected obliquely, maybe from the ground reference point, or maybe it is projected from certain height. So let's discuss the case of the projectile. We are starting with projectile motion obliquely. Let's start with the case of motion of a projectile projected obliquely from ground reference point. That means we are taking, this is the horizontal reference level. O is the point from where we are throwing a body with velocity v at an angle theta with the horizontal. So its path will be shown like this. We'll take the different points and what is the velocity there at different points. We'll just try to explain all those things. First of all, let's assume that if v is the velocity at an angle theta with the horizontal direction, if you resolve the component of the, if you resolve velocity in the horizontal and the vertical direction, so we get the component like v cos theta in the horizontal direction and v sin theta in vertical direction. Remember that this v cos theta is the component in the horizontal direction, v sin theta in vertical direction. There will be acceleration due to gravity acting on the body. So this acceleration due to gravity, as it is acting in the vertically downward direction, so this is going to affect the vertical component of the velocity. It is not going to affect horizontal component of the velocity v cos theta. So this horizontal component will remain unchanged throughout its motion. But v cos sin theta, which was the vertical component at the point of projection, that is at the initial state when we have thrown the body, at that moment the velocity is v sine theta. With the passage of the time, as it is acted upon by acceleration due to gravity, so the velocity in the vertical direction will go on changing. This will be the point, which is the point we call it as the maximum height reached by the projectile. At this point, vertical velocity will become 0. So at this point, as the vertical velocity is 0, so the body will not rise further. So at that point, for a moment, vertical velocity is 0, but acceleration due to gravity is continuously acting. So after that, it will start falling downward due to the effect of the acceleration due to gravity. So again, its velocity will go on increasing and will start coming downward. So remember that at the point of the maximum height, it is only the vertical component of the velocity that becomes 0. Horizontal component will still be there. This will remain v cos theta in horizontal direction at all points. Even at the highest point, the velocity of the body will be v cos theta in horizontal direction. And at the highest point, vertical velocity there will be 0, but horizontal component will be v cos theta. Now let's take the different terms which we use in the motion of the projectile. One term we call it as the time of ascent. That is the time taken by the projectile to move from point of projection to the point of maximum height. Similarly, from the point of maximum height to the point where it is ending its journey, that is called as the time of descent. There is a time of flight term used for the total time taken by the projectile in its entire motion. That is the time lag between the time at which it is thrown to the instant when it is ending its journey. So let's try to find out the expression for all these terms. Time of ascent. This is the time taken by the projectile to move from point of projection to the point of maximum height. So here, initial vertical velocity, if you consider vertical velocity, this is your v sine theta. And at the maximum height, vertical velocity, this will be 0. So if you use the formula v equals to u plus at, so at the point of maximum height, this v will be 0. We get v equals to 0 at the maximum height. Initial velocity, this is your v sine theta. This is v sine theta, g, and this is the time of ascent. So from this we can get time of ascent equals to v sine theta by g. This is the expression for time of ascent. We can find time of flight also. So this is the time of flight. This we represent by capital T. Time of flight is the total time taken by the projectile in its entire motion. So that will be the time from the point of projection to the point where it is ending its journey. So this entire time duration will be the time of flight. So if you consider its entire motion, here net vertical displacement will be 0 because we have thrown it from the point here, and suppose it is ending its journey at the point A. Both are at the same horizontal reference level, so the net vertical displacement will be 0. So net vertical displacement in entire journey, this is 0. Now why it is 0? Because the point of projection and the point where it is ending its journey, both are lying at the same reference level, and that is the same horizontal reference level. So that is why the net vertical displacement will be 0. Remember, if our plane would have been here like this, suppose if it would have been like this, there the vertical displacement would not have been 0, because then this would have been the net displacement in the vertical direction. Or if suppose the inclination is there up to this particular point, it is ending its journey here on the inclined plane, so there also it will not be net vertical displacement 0. Only in this case, when the point of projection and the point where it is ending its journey are at the same reference level, then we are taking the net vertical displacement to be 0. So again, if you use S equals to ut plus half at square formula, so the net vertical displacement is 0. Initial vertical velocity that we have taken v sine theta, so this is your v sine theta into t, that is the time of flight, minus half gt square, or t will be equals to 2v sine theta by g. So this is the expression for time of flight. Now, suppose we take another term, that is the time of descent. And this will represent it as Td. Now, time of descent will be the time taken by the projectile to move from the point of maximum height to the point where it is ending its journey. So obviously in this case, if you consider, we have time of ascent, time taken by the projectile to move from point of projection to the maximum height, and time taken to move from maximum height to the point where it is ending its journey, this is the time of descent. So the sum of these two, this is equals to time of flight. So we can write that time of descent will be t minus ta. So it is your 2v sine theta by g minus v sine theta by g, and that is your v sine theta by g. This is Td. So what we find here, Ta, which is your v sine theta by g, Td is also v sine theta by g. So we find here time of ascent is equals to time of descent. But will it always be equal? No. It will be equal only when the point of projection and the point where it is ending its journey is at the same horizontal level. So remember, time of ascent and time of descent are equal only when the point of projection and the point where it ends its journey both are at the same horizontal level. If the two are lying in the same horizontal level, then only the time of ascent and time of descent will be equal. Let's take a case when the body is projected from certain height. This is the point from where the body is projected. Okay, so it is moving and following the path like this. So it is thrown from this point with velocity v, it follows the path like this. So time of ascent will be the time taken to move from this point to this. So this is your time of ascent. And the time taken to move from point of maximum height to the point where it is ending its journey, that is your time of descent. So obviously in this case, Ta will be less than Tt. When we are getting that, when the point of projection is at certain height with respect to the point where it is ending its journey, so then time of ascent will be less than time of descent. Other case may be there, like when it is thrown from a lower level and suppose it is ending its journey at a higher level. It is thrown from this point, it is ending its journey here. So here, this is suppose the point, and here it is thrown with velocity v. So it rises from this point to the maximum height, time taken is Ta, and here this time taken is Td. So obviously in this case, Ta will be greater than Td. When we get this one, this we get when the point of projection is at lower level with respect to the point where it is ending its journey. If the two are at the same horizontal level, in that case both will be equal. Let's now take the expression for maximum height reached. This is the maximum height reached that we represent by capital H here. So next is maximum height reached. Now again, for finding this one, at maximum height, vertical velocity is 0. So using v square equals to u square plus 2as relation, we get here 0 square, or just 0 basically. We get 0, that is v square. Initial vertical velocity is your v sine theta, so it is v sine theta whole square minus 2gh, or h will be equals to v square sine square theta by 2g. This is the expression for the maximum height reached by the projectile. Here, suppose we want to know what can be the maximum height that can be reached by projectile. There is a difference between the two terms. This is the maximum height reached. That means when the projectile is thrown at some angle with the horizontal or vertical, so in its motion, what is the height up to which it rises? And the other one is when the projectile is thrown with a particular velocity, what is the maximum height up to which it can rise vertically? So for that, if you consider maximum height that can be reached, so that we represent it as h max. So h max is basically maximum height that can be reached by that particular body there. So that is basically h max is, it is the maximum value of this h. So if it is your v square sine square theta by 2g, it is the maximum value of this. Now what can be the maximum value here? This will be equals to v square by 2g when sine theta is 1. And sine theta is 1 means theta is pi by 2. Theta was the angle with the horizontal. So that means the body should be projected exactly in the vertical direction. So if you want that a body which is thrown with velocity v, it rises up to the maximum height, then it should be thrown exactly in the vertical direction. Then it will rise up to a height which is your v square by 2g. So h max value will be v square by 2g. This is the maximum height up to which the body can rise. Next is horizontal range. Horizontal range is the horizontal displacement made by the projectile in its entire journey. Like if it is thrown from this point and it is ending its journey here, so this particular distance, this is r. So if you have to find the expression for horizontal range, this will be equals to horizontal velocity multiplied by time of flight. So that will give the horizontal range. Now this is horizontal velocity is your v cos theta, and time of flight is 2v sine theta by g. So that means this can be written as your v square by g. It is 2 sine theta cos theta term, and this is your v square by g, and this is your basically sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So this is your sine 2 theta. So this is the expression for the horizontal range. This will give you the horizontal displacement made by the projectile in its entire journey. Again, here also we can try to find out what can be the maximum horizontal range. So for maximum horizontal range, that we represent it as R max. So this R max is basically maximum value of R. So this will be equals to V square by G sine 2 theta's maximum value, and which is your V square by G when sine 2 theta is 1. That means 2 theta is pi by 2 or theta equals to pi by 4. So R max is V square by G, and this happens when theta is pi by 4. So remember, for maximum horizontal range, the body must be projected at an angle 45 degree with the horizontal. So then it will give you the maximum horizontal range. But there is a catch. When we say it is the maximum horizontal distance that can be reached or that can be attained, that is your V square by G, and for that the angle of projection should be 45 degree. Angle of projection will be 45 degree for maximum horizontal range only when the point of projection and the point where it is ending its journey, they are at the same horizontal level. If they are not at same horizontal level, in that case, the angle of projection will be slightly different from 45 degree. Let's just try to understand. If you want to throw a body to the maximum vertical height, we want to throw so that it rises up to the maximum vertical height, then it should be thrown exactly in the vertical direction. But if you want that the body should travel through maximum horizontal distance, then it should be thrown at 45 degree with the horizontal. That is why you must have noticed in the javelin throw, they throw it at some angle with the horizontal. If you observe it minutely, it will be there roughly at 45 degree. Because there the aim is there to throw it to the maximum horizontal distance. Similarly, in football, if suppose any player is kicking a ball and they want the ball should go to the maximum horizontal distance there, in that case they kick it at some angle, and the range will be maximum when it is kicked at 45 degree, if you neglect the air resistance and other there. So there it is 45 degree. But is the horizontal range maximum at only 45 degree or exactly 45 degree? It is maximum at 45 degree only for the case when it is thrown such that point of projection and the point where it is ending its journey, they are at the same horizontal level. If they are at the same horizontal level, then only the angle of projection should be 45 to get maximum horizontal range. But if it is thrown from certain height, in that case, for maximum horizontal range, the angle of projection should be slightly less than 45 degree. Like suppose if I assume that we are throwing a body from certain height, from the top of a building we are throwing a body with velocity v, and we want that it should have the maximum range here on the ground. Then here this particular angle for maximum horizontal range will be slightly less than 45. You can derive that expression by taking help of maxima and minima for a given height h. If it is thrown with velocity v, what should be the angle of projection to get the maximum range, horizontal range? They will find that it depends upon h there along with the v and along with v there. So there you'll find that if it is thrown from certain height, the maximum horizontal range will be obtained, and for an angle which is slightly less than 45. If you put in the formula, this h term will also be there, and that will make this angle of projection slightly less than 45. At the same time, suppose you want to throw a body from lower level. In that case, for maximum horizontal range at a higher level there will be slightly more than 45. Like if you are throwing it from lower level, and if this is being thrown and it rises and strikes here, suppose. So for this angle will be slightly more than 45 degree. It is exactly 45 only when the point of projection and the point where it is ending its journey are at the same horizontal level. Let's now take equation of trajectory. That is the equation of path of the projectile. So suppose we assume that let x be horizontal displacement in time t. So, and y is vertical displacement in time t. So obviously x, what we can write? This will be v cos theta, horizontal velocity, multiplied by the time. So t will be equals to x by v cos theta. Suppose I call it as equation number 1. Now for y, if you take, that is the vertical displacement. So this will be ut plus half at square formula we are using. So initial vertical velocity was your v sin theta t minus half g t square. And here in this expression, if you substitute for t, so putting for t, y will be how much? V sin theta multiplied by t, that is your x by v cos theta minus half g x by v cos theta whole square, and that can be written as your x tan theta, because v will get cancelled, so it will be your x tan theta minus half g x square by v square cos square theta. This is the equation of trajectory. So this is the equation of trajectory. That means this gives you the expression for the path of the projectile. When you have a particular value of x, you can get the particular value of y there. So for any particular position, if you consider, suppose this is the point, this is x, this is your y, this is y, this is your x. So at any particular point, what is the relation between x and y? That is the vertical displacement, horizontal displacement. If you know what is the velocity with which it is projected, at what angle it is projected, you can get it from this. Moreover, this gives you the equation of the path of the projectile in its entire motion. Now you can see this is in the form of equation of a parabola. So it is in the form of equation of a parabola. Because it is just like y equals to ax plus bx square. So this is the equation of a parabola. Hence, path of the projectile will be parabolic. Path of projectile is parabolic. So this is the parabolic path acquired by the projectile. Importance of this equation of the trajectory is that this will also give you expression for the height of the projectile when you know what is the horizontal displacement. Or suppose you want to know at this particular horizontal displacement, what is the vertical height reached by the projectile. So you can take help of this equation and you can get that value. Suppose we take in space. So in a space, g will be 0, acceleration due to gravity will be 0 there. So in that case, if you substitute here, then what we'll get? Y is equals to x tan theta minus 0, because this term will be 0 there. So this is your y equals to x tan theta. This is the equation of a straight line, which is in the form y is equals to mx. So as this is in the form of equation of a straight line, therefore the path of the projectile in a space will be a straight line path. Remember, why it will be a straight line path? Because acceleration due to gravity is not there. Acceleration of the gravity was always changing its velocity in the vertical direction. It has one component of the velocity in the horizontal direction. That is why it was able to move in the parabolic path, because its velocity is changing in vertical direction. It has the horizontal velocity at any particular moment there. So resultant velocity was changing its path. Or you can just think that as acceleration due to gravity is there, which is trying to pull it. So in that case, its path will be modified. But in a space, there is no g, no acceleration due to gravity is there. So if it is not there, its path will not be modified. So if it is thrown with a particular velocity, it will continue moving in that particular direction there in a straight line path. That is why in space, the path of the projectile will be a straight line path.